Hey everybody, so I'm going to put together a quick video on how to perform a block average in Homer2 and describe exactly what's going on in the background. So here's your data. This is a motor task. It's left and right hand finger tapping, and you notice over here I have my left hemisphere, my right hemisphere. I'm looking at these channels right here, A1 and B1, which is 1-1 and 2-1. So I have both channels coming in here. I'm looking at wavelength 760. I can also look at 850 if I want it. I'm looking at raw data. If I want to run it, I go ahead and click run, but just to show you, if I click options, I get something like this. Normally you'd have a default pipeline, but this is just a very, very simple block average pipeline. Basically, I have an intensity value converted to optical density. I look for motion artifacts with a standard deviation of 12. I reject any stimulus that fall within a motion artifact within the time range of -5 seconds and 30 seconds. I convert to concentration, and then I perform a block average over the -5 seconds to 30 seconds. So have my, I run it. It detects two motion artifacts here denoted by the pink lines, and it removed this stimulus due to the fact that there was a motion artifact right next to it. I'm also looking at optical density. Back up. I'm looking at optical density as opposed to raw data. Here, if I want to click concentration, I can view concentration, and next you can actually look at the HRF. So the HRF is basically your block average now. If you did a general linear model, you'd actually see a weighted beta. But here I have an HRF. I did not filter it, so therefore you can still see the heart rate. And you'll notice here's the 0-second mark. It's 0 mean, and here's the response. So what's going on in the background? Here's my original data set. If you notice the HBO, this is HBO, HBR, and HBT. HBO is in blue, HBR is in red, and HBT is in yellow. So it starts out at the 1 mark. Well, it actually gets shifted during the block average to a 0 mean. In that shifting, you can see that the HBR was shifted by about 1. The HBO was shifted by about 1, but shifted in the upwards direction. And the HBT was shifted upwards about 1, and the HBO was shifted up about 2. If I use the export mean function, it will actually give me 3 different values for the time range selected for each condition and for each channel. There's 3 values because it's HBO, HBR, and HBT. And if you notice, these are all singular values, and they're on a scale of 10 to the -7th. So these are still 0 mean. Still is basically stealing it from the original, and but it gives you essentially a single value for that time range as opposed to a full time range. Anyway, I hope this was helpful, and if you do have questions or request a video, please let me know.